Okay, let's see how this works. All right. Well, if we're trying to make a prediction about whether something's highly soluble, there are lots of things that you can do that. Now, with ionic substances, we haven't really studied the kind of things that will allow you to make predictions based on structure. Okay? But there are a lot of things about the structure of ions in an ionic compound that can lead you to some reasonable general assumptions about solubility. I mean, when you start looking at the shape and size and charge and things like that, there are some commonalities that come up. We haven't looked at those in here. All right? So basically, you're going to look at what I've taught you in here was to look at the solubility rules, okay, and make that the way you're going to judge it. That make sense? All right. But when we're talking about polar substances, Waverly, do you have a question about that?
Well, like the actual answer to that is the solubility rule?
No.
That's in this ion. These are polar. Okay.
I'm explaining the big picture and let you actually answer the question. If you want me to answer specifically the question, it may not help you as much because the question on the test may be different. That make sense? So understanding the big picture behind the answer that you provide is going to help you with that category of information. That's what I'm trying to give you. The big answer I've given you part of. Okay? The other part has to do with the polarity. Okay, the polarity. So there's actually two things going on. If I have particles that are pulled together into some solid, and the liquid needs to separate it, that is to say, solvate it. Remember the solvation process? Okay? Then, first of all, the liquid has to be able to overcome what's holding the crystal together. Okay? To split it apart. So you got two things going on. There's a strength of attraction between particles, and there's a strength of the pull of the solvent to separate those particles. Okay? So when we're talking about ionic compounds dissolved in water, water is very polar, and so those polar ends, we talked about how they surround those ions, provide all of the negative or positive charge those ions need, and eventually allow them to kind of break off and become part of the solution. Okay? With polar substances, it depends on how polar it is. Okay? So everything is relative, actually. If I have a small alcohol like ethanol, and I'm going to use a kind of a in-between version of structural drawings. This is kind of complete structural, and it's condensed on this side. But I'm also going to stick a couple of lone pairs up here because those are important to this. All right, so this is a small alcohol. And then water, remember, has hydrogens covalently bonded to oxygens, and it has a couple of lone pairs too. Okay? Well, this hydrogen can actually hydrogen bond to that oxygen. And another water molecule can hydrogen bond to that lone pair. And another water, the lone pair on another water, can hydrogen bond to this hydrogen. Lots of places for hydrogen bonding to occur between this water molecule, or these three water molecules, and this alcohol. At the same time, this end of the molecule is nonpolar, making that end of the molecule hydrophobic while this end is hydrophilic. Hydrophilic means it likes water. Anybody know what the name Philadelphia means? City of brotherly love. Philia is a Greek word, or as a root in a Greek word. I forget if that's exactly right. That means it's a type of love. It's like brotherly love. Okay? Aww. And it's named for a city in the Bible. Okay? On the other hand, this side of the molecule is hydrophobic. Okay? Hydro meaning water. Phobic meaning what we think about it being afraid of.
Yeah, like claustrophobic.
Like claustrophobic or arachnophobia.
Arachnophobic.
Yeah.
Or lactophobic.
Okay. So the ability of water to dissolve this alcohol is a balance between the amount of attraction there is between the water molecules and this end of the molecule, and the opposite effect going on this end, which doesn't want to dissolve in the water. Okay? Actually, the water don't want to dissolve that. That's really a better way of saying that. Water's kind of cliquish. Because of its polarity, it sticks together and it kind of pushes out that end. So if I have a really long chain molecule, so this is completely miscible. All right, it's really easy to dissolve this small molecule of alcohol. But if I have a really long chain alcohol,
Just keep going.
how far do I keep going? Anybody want to tell me to stop?
No, keep going. We'll tell you when to stop.
Well, I'm running out of space, so I better stop.
No,
Okay.
you got another one.
All right.
You got
Well, now
space in the beginning.
this end wins.
Oh.
And this alcohol is pretty much insoluble in water. That makes sense? So it's all a matter of structure, making predictions about how much of the construction of a particle, a structural particle, is able to interact effectively with whatever your solvent is. Okay? If your solvent is nonpolar, this stuff dissolves pretty easily in that. I can dissolve this in alcohol all day long. I mean, not in alcohol. I can dissolve this in gasoline all day long. Okay? But even though this end is polar over here, it still dissolves in alcohol, where water doesn't tend to do that. Right? But here's a cool thing. This end dissolves in the gasoline. This end kind of doesn't want to.
Right.
But I can get water and gas. You've ever heard gasoline and water don't mix?
Yeah.
But they will if you put alcohol in there.
Oh.
Because the alcohol, this end of the alcohol mixes with the gasoline, and this end mixes with the water. Okay? I got a very interesting email. I'm on a it's kind of a listserv thing where you have teachers and scientists and things that answer questions for students and other teachers.
Like Cha-Cha. Like Cha-Cha.
Well,
like Cha-Cha.
no, I have a.
Are you on Cha-Cha?
Oh, I guess I haven't put it up yet. No, it's called Newton.
Thing you like text them, Newton Physics.
No,
Newton.com.
it's an email system. Anyway,
Newton.org.
what they do is students will send in their questions, and somebody at the Argonne National Labs, I think it is, sends it out to these different groups, and then you answer the questions if you want to. And so I got a very interesting email yesterday from a student who was claiming that small organic hydrocarbon chains like ethane, methane, maybe not methane, I don't think they mentioned that. They mentioned maybe propane, butane, things like that will dissolve in gasoline. And fuel oil will dissolve in gasoline. But if you put both in there, then the small chains, the gaseous chains, actually don't dissolve very well anymore. And that's a really interesting question but that's about the interaction between all these particles. Okay, so it's a matter of there isn't always one single answer. It's how you answer that's important. It's whether you can draw in the stuff you know about science to make a prediction or a model that has to do with what the best possible answer is. Okay? I never heard that before, and that's really interesting. I even asked the person to give me their source, where they get the information from, because that's something that I had never heard before.
That's something else.
But I think it's probably related to that thing we did with the little beads in the water and the salt and the alcohol. Yes. Yes, Misha. All right. So have I? Okay, hold on. Did I answer your question sufficiently, Molly?
Kind of. What would something be that's somewhat soluble look like?
That would be somewhat soluble in water.
I thought that was like mostly insoluble.
Well, mostly insoluble is like somewhat soluble. Depends. Let's say I've got a chain that's not quite that long. Say CH3, CH2, 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 and then the OH group. Okay? That might be somewhat soluble. Okay? So it's a balance. Okay?
What if you had an OH group on both ends?
Oh, that would increase the solubility. That would increase the amount of solubility. If you got an OH group on both ends.
But would it be somewhat soluble, or
It depends.
how greatly would that affect the
It would increase well, how greatly. That's a relative term. I would say it greatly affects the solubility. Okay? So, sometimes we discuss things in a science class in relative terms, greatly affects. But scientists don't like relative terms because they're so much open to interpretation. Okay? They prefer quantitative answers, and I don't have a quantitative answer for you. Okay? But there is let's just say there's clearly a significant effect in the amount of solubility. Okay? And if you have sugar, I mean, that's got OH groups sticking all over the place. Well, those are really highly soluble. Okay? In fact, sugar, if you raise the temperature of sugar and water up to, I don't know, 50-something degrees centigrade, somewhere around there, it starts to create what's called an azeotrope. And then you can you no longer have a limit on the amount of sugar you can dissolve. So you reach a certain point where you can put as much sugar as you wanted to in there, and you get at that point you get a syrup.
What?
Yeah. Syrup is basically sugar and water in an azeotrope.
Comes out of trees?
Sugar that comes out of any plant. All plants make sugar.